Hello students, welcome back to our maths class. In the previous class we have seen the introduction about the arithmetic progression. Today in this video we are going to learn how to do the solution of examples in exercise 2.5. First let us recall some important points of an arithmetic progression. In an AP, the general form is A plus D, A plus 2D and so on. Next we see the nth term of an AP is Tn is equal to A plus n minus 1 into D. Here A is first term, D is common difference and n is a nth term. The next point, number of terms of an AP is equal to L minus A divided by D plus 1. Here L is a last term, A is a first term, D is a common difference. The three consecutive terms of an AP is A minus D, A plus D. Here the common difference is D. Then the first four consecutive terms of an AP is A minus 3D, A minus D, A plus D and A plus 3D. Here the common difference is 2D. These are the important points to remember of this exercise. Let us do the example 2.26. See the question. Find the number of terms in the AP 3, 6, 9, 12 up to 111. In this question, AP is given. We have to find the number of terms. Then means which formula you have to use? Yes, n is equal to L minus A divided by D plus 1. Let us do the solution. In solution, first you take down and write the given AP. The given AP is 3, 6, 9, 12 up to 111. Here A is equal to 3 and D is equal to 6 minus 3, that is D also 3. Here L is equal to 111. In this question, we have to find the number of terms. Therefore, the formula number of term n is equal to L minus A divided by D plus 1. Now, you have to apply this value in this formula, means we get n is equal to, here L is 111 minus A is 3 by D is also 3 plus 1. Now you have to simplify this, means we get n is equal to 111 minus 3 is 108 by 3 plus 1. Now you have to can 3 table, we get 1 3 is 3, 3 3s are 9, remainder 1, 6 3s are 18. Therefore, n is equal to 36 plus 1, that is 37. Hence, the number of terms in an AP is the number of terms in a given AP is 37. This is the answer for this question. Now, we move on to the next example, 2.28. See the question. If Lth, mth and nth terms of an AP are x, y, z respectively, then show that x into m minus n plus y into n minus L plus z into L minus m is equal to 0. In this question, Lth, mth and nth terms of an AP are x, y, z is given. That is, TL is equal to x, Tm is equal to y, Tn is equal to z. We have to verify the given subdivisions. Let us do the solution. In solution, first you take down and write the given. It is in an AP, TL is equal to x and Tm is equal to y and Tn is equal to z. Now, we have to use the nth term formula for this given. The formula is Tn is equal to a plus n minus 1 into d. Now, you have to apply this formula for the given, that is TL implies a plus, instead of n here given L, so L minus 1 into d is equal to x. Similarly, you have to write Tm implies a plus, instead of n you put m minus 1 into d is equal to y. Then next Tn is equal to a plus n minus 1 into d is equal to z. These are the given in the question. Take down and write the left hand side of the given, that is x into m minus n plus y into n minus L plus z into L minus m. Here you have to apply these equations instead of x, y, z. Let us see. For x, you have to write a plus L minus 1 into d into m minus n plus, instead of y you have to apply this one, that is a plus m minus 1 into d into n minus L plus, instead of z you have to apply this, that is a plus n minus 1 into d into L minus m. Now you have to simplify this. First you have to remove the inside bracket, that is a plus LD minus d into m minus n. First you have to remove inside the bracket term, that is L into d and d into minus 1, here m into d and d into minus 1. Here n into d and minus 1 into d, or you get a plus LD minus d into m minus n plus a plus md minus d into n minus L plus a plus nd minus d into L minus m. Now you have to multiply these two bracket terms, that is m into a, then m into ld, m into d. Then next minus n into a, minus n into ld, minus n into d. Similarly, you have to multiply for these terms also. Let us see. Now, you have to simplify this carefully. That is, first you have to multiply by m. am plus lmd minus md. Plus into minus minus. Next you have to multiply by minus n. That is minus an minus nld plus nd. Plus minus into minus plus nd. Then next you have to simplify the next term. That is, first you have to multiply by n with this term. Then next you have to multiply by minus L with this. Plus an plus mnd minus nd minus al minus mld minus into minus plus ld. Next you have to multiply the last term, that is plus L into al plus L into nd nld minus L into d ld, then minus m into a minus am minus m into nd minus mnd minus m into minus d plus md. Now you have to cancel the like term. Plus am minus am, next plus lmd minus mld cancel, then minus md plus md cancel, minus an plus an cancel, then next minus nld plus nld, minus nld and plus nld cancel, then plus nd minus nd cancel, then next minus al plus al plus ld minus ld, then plus mnd minus mnd. So all the term here, all the terms are cancel and get 0. So here all the like terms are cancel, which is equal to, we get, which is equal to 0. It is implies RHS, right hand side. Therefore, hence verify that x into m minus n plus y into n minus l plus z into l minus m is equal to 0. Now, we see the second subdivision. You have to verify this given. That is, Here you have to verify x minus y into n plus y minus z into L plus z minus x into m is equal to 0. In solution, first you take down and write the given, that is a plus L minus 1 into d is equal to x. You have to simplify this, means we get a plus LD minus d equal to x. This one we take first equation. Then next given Tm is equal to a plus m minus 1 into d is equal to y. You have to simplify this, means we get a plus md minus d equal to y. This one you take second equation. Then next given Tn is equal to a plus n minus 1 into d is equal to z. Here similarly you have to simplify this, means we get a plus nd minus d is equal to z. This one you take third equation. Now you have to apply this equation in the LHS term. Let us take left hand side, that is x minus y into n plus y minus z into L plus z minus x into m. First you have to find the bracket term value. First you have to find the value of bracket terms. That is, now you have to find the bracket term, that is x minus y, which is equal to x term. The equation of x is a plus LD minus d minus of the equation of y term a plus md minus d. Now you have to remove this bracket, means we get a plus LD minus d minus a minus md plus d. It is here plus a minus a cancel, then minus d plus d cancel and get x minus y is equal to LD minus MD. Then next you have to find y minus z, that is second equation, y equation a plus md minus d minus of z equation a plus nd minus d. Now you have to remove this bracket, means we get a plus md minus d minus a minus nd plus d. Here also plus a minus a cancel and minus d plus d cancel and get y minus z is equal to md minus nd. This is the value of y minus z. Next you have to find z minus x, which is equal to z equation a plus nd minus d minus of x equation a plus ld minus d. Now you have to multiply. Now you have to remove this bracket, means we get a plus nd minus d minus a minus ld minus into minus plus d. Here you have to cancel plus a minus d plus d. Therefore, z minus x is equal to nd minus ld. Now you have to apply these three values in the left hand side term. Now you have to apply these three values in left hand side. That is the left hand side is x minus y into n plus y minus z into L plus z minus x into m, which is equal to x minus 1 is LD minus MD. So here you have to write, instead of x minus y, LD minus MD into n plus y minus z is MD minus ND. That is, instead of y minus z, you have to write MD minus ND into L plus z minus x. For this you have to apply this. You have to apply ND minus LD into M, which is equal to, that is, N into LD, NLD minus MND. Then next you have to multiply with ML plus MLD minus NLD plus MND minus LMD. Now you have to simplify this. Now you have to simplify the like terms. Plus NLD minus NLD cancel and get 0. Minus MND plus MND cancel. Then plus MLD and minus MLD cancel and get 0, which is implies RHS, that is right hand side. Hence verified that x minus y into n plus y minus z into L plus z minus x into m is equal to 0. Now we move on to the next example 2.29. See the question. In an AP, sum of 4 consecutive terms is 28 and their sum of their square is 276. Find the 4 numbers. In this question, sum of 4 consecutive term and sum of their square also given. We have to find that 4 numbers. In solution, you have to take the 4 consecutive terms of an AP. Let us do the solution. In an AP, let the 4 consecutive terms be A minus 3D, comma A minus D, comma A plus D and A plus 3D. Already we studied this in the introduction part. Now you have to apply this next you have to write. Now let us see the given sum of 4 terms is equal to 28, that is a minus 3d plus a minus d plus a plus d plus a plus 3d is equal to 28. Now you have to simplify the like term. Here a 4 times having, so a plus a plus a plus a add means we get 4a, then minus 3d plus 3d cancel and get 0, minus d and plus d are also cancel and get 0. Therefore 4a is equal to 28, that is a is equal to 28 by 4. Now you have to cancel this by 4 table, means we get 1 4 is 4, 7 4s are 28, that is a is equal to 7. Here the value of a is 7. Next you have to write the next given, that is sum of their square. Sum of their square is equal to 276, that is a minus 3d the whole square plus a minus d the whole square plus a plus d the whole square plus a plus 3d the whole square is equal to 276. Now you have to simplify this by using identity, that is a minus b the whole squared is equal to a squared minus 2ab plus b squared. Then a plus b the whole squared is equal to a squared plus 2ab plus b squared. Therefore a minus 3d the whole squared is a squared plus 9d squared minus 6ad. Next you have to apply the identity for a minus d the whole squared, that is a squared, then b squared plus b squared, that is plus d squared, then minus 2ab, that is 2 minus 2ad. Then next a plus d the whole squared is equal to plus a squared plus d squared plus 2ad. The next one a plus 3d the whole squared, that is a squared plus 9d squared plus 6ad. Here you have to simplify the like term, that is plus 6ad minus 6ad, then plus 2ad minus 2ad cancel. Therefore you have to simplify the remaining terms, that is here a squared is 1 2 3 4 times, so 4a squared, then 9 plus 1 10, 10 plus 1 11, 11 plus 9 20 plus 20d squared is equal to 276. Here you have to apply the value of a. In the previous step we have value of a is 7. You have to apply 7 instead of a, that is 4 into 7 the whole square plus 20d squared is equal to 276. Here 7 squared is 4 into 49 plus 20d squared is equal to 276. Now 4 into 49 is 196 plus 20d squared is equal to 276. Now you have to transpose this 196 after the equal means it becomes minus. That is 20d squared is equal to 276 minus 196, which is equal to 20d squared is equal to 80. Therefore, d squared is equal to 80 by 20. Cancelling this means we get 4 20s are 80. Therefore, d squared is equal to 4 and d is equal to plus or minus 2. Square root of 4 is plus or minus 2. Now, we have the value of a is 7 and d is equal to plus or minus 2. Now, let us write the 4 terms. The 4 terms are a minus 3d, a minus d, a plus d, a plus 3d. Next, you have to write if a is equal to 7 and d is equal to 2, then the 4 terms are 7 minus 3 into 2, 7 minus 2, 7 plus 2, 7 plus 3 into 2. That is, you have to simplify this means we get 3 2s are 6, that is 7 minus 6 is 1, 7 minus 2 is 5, 7 plus 2 is 9, then 7 plus 6 is 13. Hence, the 4 terms are 1, 5, 9, 13. Next, you have to find if a is equal to 7 and d is equal to minus 2, then the 4 terms are 7 minus 3 into minus 2, 7 minus into minus plus 2, 7 minus 2, 7 plus 3 into minus 2. Now you have to simplify this means we get the 4 terms 13 minus 3 into minus 2 plus 6, so 7 plus 6 is 13, then 7 plus 2 9, 7 minus 2 5, then 7 3 into minus 2 minus 6, 7 minus 6 is we get 1. Therefore, the 4 terms are of an AP is 1, 5, 9, 13 or 39, 5, 1. This is the answer for this question. Today homework exercise 2.5 third sum and fourth sum. Do it properly. Thank you.